Yo. We got this problem. This was a really cool problem. This was a really cool problem. One of the code problems on DP. Why haven't I saved it? Elegant, DP Dumpy Don, full style base. No, this is Dan. Top 100 hearts and mediums. So let's have a look at this. What is this trying to say? What you trying to say, dog? Minimum distance to type a word using two fingers. We are given two fingers. Everybody has two fingers. Nothing crazy. Then what? With two fingers, what? Okay, let's turn on the camera again. Video capture is on. So today, let's solve the problem LeetCode 1320. Minimum distance to type a word using two fingers. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z has been arranged in a width 6 matrix. So the width is 6, it's clear that it's a 4 and this 2, 6, 12, 18, 24, 24 to 26. You have a keyword as shown layout, XY plane, where each English uppercase letter is located at some coordinate. Coordinate is 0, comma 0. This is 0, comma 1. This is 1, comma 0. This is 1, comma 1. This is 2, comma 3. Yes, 0, 1, 2, 3, 0, 1, 2. 2, comma 3 is this. And for example, the letter A is located at 0, comma 0. Letter B is located at 0, 1. And P is located at 2, 3. Z is located at 4, comma 1. Z is yep. Given the string word, return the minimum total distance to type such letter using two fingers. We have two fingers. If we can just use any of them to press any of the key. If the keys lies in this corner, we will use this finger. If the keys lies closer to this finger, we will use this. Let's say if this key has been kept at A, this has kept at P. So A and P. And next key we have to press is O. So it's definitely sure that we will use this finger to press that key rather than using this finger. But we don't know like if this was a good way or not. The greedy thing won't work because it depends on the total simulation of the entire thing and all the cases we have to cover. So it's for sure a DP problem. Given the string word, return the minimum total distance to type such string using only two fingers. Distance between the coordinates that has been moved from x1 y1 to x2 y2 is given as this absolute difference uh, distance. I guess it is called Manhattan distance also. Search more problems on Manhattan keyword and you will find a lot of problems based on this distance. Note that initial positions. Oh man, everybody just solved it in what you say daily problem and increase the acceptance rate for this one. Remove covered intervals has been done, so fuck it. Minimum distance. Yep, resolving this one. This one is a really cool problem. This is the Manhattan distance. Note that the initial position of your two fingers are considered to be free. So do not point towards your total distance. So initially, the two fingers are free. We can point them anywhere we want to keep them. Also, your two fingers do not have to start at the first letter of the or the first two letters or something like that. These are just two free fingers. So the first two costs are free. So if I will press A and P, then cost added will be zero because these fingers haven't been used. And let's say if on the third time I go from P till zero, then the distance added is plus one. So let's see cake. C, I will press I'll use C and I will go here. This distance is 2. I'm using this finger one. I will press K. Where the fuck is K? Here. And E. This is one distance, so total distance is 3. This is the entire logic. So let's see how I have solved it. This problem solution I think I got from Kernel Queen. Kernel Queen. She got a YouTube channel. So I have defined a helper function that gets me the distance from the previously pointing finger to the new pressed finger and based on which finger has been used. Okay. Okay. So this is the define f function. It is pointing at the current index I of the string word and position 1 and position 2 represent the current position of finger 1 position and finger 2 position. And this I represents the current character index in the word string of word cake. So if I reaches n minus 1, we return 0, goes out of bound. And current position is given by odd of s of I minus s of this a. So yep, I've got this number, and from this I am getting the list. If the finger one is used to press this key, if finger one is used to go from pause 1 to current pause, so the cost will be get dist of pause 1 till current pause plus f of recursive function of I has been moved forward from here till to here. I has been shifted in the words string, and pause 1, the previous position was pause 1, has now become current pause by using the finger 1. That's it. And similarly for this 2, if finger F2 has been used, so get dist F2 is the, like the previous finger was pause 2, and the current position is current pause, and the recursive distance got from the distance such that I has been moved forward. I has been moved forward in this direction in the string, and pause 1 will stay at pause 1 only, and pause 2 will become current pause because finger 2 has been used. So this will become current pause. This is the next recursive call. Similar for this one and this one, get minimum of dist 1, dist of f1 comma dist of f2, and return 0 and minus 1 comma minus 1. That's the entire crux of this problem. And get dist function has been defined as x1 y1 x2 y2 are the previous positions, x coordinate that will be divide, and y coordinate that will be modulo, divide and modulo for the current position. And if the previous position is pointing at minus 1, this means the finger has not been used earlier, return 0, otherwise return absolute of x1 minus x2 absolute of y1 minus y2. That is the definition of this Manhattan distance that has been asked. If pos 1 has been, so the crux was dp state was f of I comma pos 1 comma pos 2. I is needed to represent what index we are at for the string that has been asked for in the question, and pos 1 and pos 2 represents the position of the fingers of both the fingers. And when the I reaches out of bound, we just return 0, and current position is got based on where we have to go. This is the position where we have to go, that has been calculated this way. Dist is, if dist f1 is used, so from pos 1 we are going to pos current pos. If f2 is used, so we are using f2 at position 2 and moving it to current pos. So this is the distance, and after that we are recursively calling. So when f2 has been used, so f2 pos 2 will become current pos, and Current pause will become pause one. Yes. And we are calling it with minus one just to indicate that we are using uh like initially the F1 and F2 are not being used. So this is the solution in which I have used this cache style. What's up, man? It got broken or what? Bitrate has been reduced. It's getting unstable. Your video is back. So this one was the solution using the normal cache. And let's look at the solution I did. This is normal cache only. This is the solution I did using. This is fucked up. Leave it. Manual DP I can do. I have done this cache thing. Just defining it is needed. All right. So we are done with this problem also. This had a constraint of only 300. I solved it on 13th April. And this required 3 DP states only. That's it. Let's do another lead code hard. I did some factory thing. Robots and factories. Minimum total distance travel, no. Number of ways to divide a long corridor, no. Oh yes, minimum total distance travel by the factory robots. There's problem. I don't know if Twitch is working fine or what. I will just end it here once. Or should I? And is this? Yup, I guess. Okay, let's do this. So this problem. Minimum total distance traveled by the robots to get repaired in a factory. We are given robots and factories at places. Let's read the problem statement. There are some robots and factories on the x-axis. You are given an integer array robot where robot of I is the position of the ith robot. You're also given a 2G integer array factory where factory of j is position of j and limit of j. Indicates the position j is the position of the jth factory, and jth factory can at most repair limit j robots. So this factory array will represent where this factory lies and how many robots it can fix, the limit of the robots this factory can fix. The position of each robots are unique. The position of each factories are also unique. Note that a robot can be in the same position as a factory. Like can be a thing that robot is there and factory is there. The robot don't have to move anywhere, just have to get fixed. So the distance traveled by robot to get fixed is zero. Might be possible. All the robots are initially broken. They keep moving in one direction. The direction could be negative or positive x direction. They can move in any direction. When a robot reaches a factory that does not has on its limit, like if a robot reached a factory that still has limit to operate some robots, so it will stop and the factory will repair it and distance will be added. At any moment, you can set the initial direction of moving or some robot. Your like the direction in which the robot will go is under our control. The target is to minimize the total distance traveled by all the robots. So we have to minimize the total distance traveled by all the robots. So the setup looks like this. We have x-axis, we have some position where factories are there, and limits are also being told of each of the factory. And a robot can come and get fixed there. It might also be possible that robot is already inside a factory and the distance travel is zero. And we have the freedom to decide in which direction the robot will move. Like the robot can move in plus x or minus x. We have that freedom to decide, and we have to minimize the total distance traveled by all the robots moved. The test cases are generated such that all the robots can be repaired. So this means that the limit of total of factories will be greater than number of robots because all the robots are initially broken and the limit should be more. Note that all robots move at the same speed. If two robot moves in the same direction, they will never collide. Two robots move in opposite direction, they will just simply pass by and ignore each other. If a robot passes a factory that is already working overtime and don't have a limit left to fix more robots, then it will just keep moving and ignore that factory and find for another factory. So it's like a highway. Robots are going from this side, factories are on the road, whatever factory is free, the robot stops there to the nearest factory. Distance traveled is y minus x, that is the j minus I or whatever. This is the robot array. The robots are at position 0, 4, 6. 0, 4, 6. Factories are at 2 and its limit is 2. And factories are at 6, its limit is 6. So the crux of this problem lies in we will assume two factories at 2 and two factories at position 6. This is the crux for this problem. Convert this thing. This will be converted into 2 comma 2, and this will be converted into 6 comma 6. So these are the coordinates. So we have 2 2 6 6, representing two factories lies at coordinate 2 and two factories lies at coordinate 6. Let's look at the solution and the approach. Oh, class solution. This is a DP question of pick, not pick. Okay. And we are sorting the robots and we are sorting the factories. All right, sorting is needed because it maps the nearest robot to the nearest factory. That's all right. The hack for this problem is creating a new factories array that will store, let's say factories was 2 and limit 2 and 6 and limit 3. Then the new factories list will look like 2 comma 2 6 6 6. This way we don't have to deal with the remaining limit of factory at that coordinate. Yes, that's what's up. That's W. That's real W. In whole, what we are doing is creating multiple factories, each having a limit of only one robot fixing. So if that factory has been picked, look for the another one. Fact, empty array we have taken, factory position and factory limit in factory, for dash times in the factory limit, fact dot append fact pause. That's what's up. That's done. Then we are doing the traversing thing or something like that. What we are doing is this is the length of the factory, this is the length of robots. Always n would be greater than m because it is said that test cases are generated that all the robots can be get fixed. So n is the number of factories multiplied by the limit of their robot fixation capacity, and m is the number of robots. So n is always smaller than m. N is always greater than n is greater than m. Always equal to. So we are using this cache thing. Cache. Cache thing. So this is the new fact thing. Define solve of I comma j, and we are running it for solve of 0 comma 0. This means I and j. What is that? I is for robot and j is for factory. J is for fact. I will keep I here and j here. If I is greater than length of robots or equal to return 0, done check in all the robots. Like if this pointer moves out of the length of this robot's array, then just return 0. Then we will just return 0. If j pointer moves length of factory, return 10 power 14. That we have, but this won't ever happen because we have enough number of factories to solve or fix every robot. So this won't happen. This is the base case. And take absolute of robot of I minus factory at j. And then we will call for this one will move ahead. This one will move ahead. This is take the current factory, or otherwise skip this factory and look for another one. Return minimum of take, comma, not take. In skip the factory, only the jth pointer, that is the factory pointer, will move ahead, while the ith pointer will stay wherever it was. So as a whole, this is a take, not take. This is the cost. This is the cost of taking. This is the recursive call. This is again the recursive call, and skipping time, the cost is 0. Return minimum of take, comma, not take. And we are calling solve 0 comma 0. That's it. I submitted it on 14th April. So the trick here is sorting first of all is needed. Yes. And creating this fact array is very much important. And we just using two pointers I and j just for the robots array and the factory array. If I goes out of bound, then just return 0. Otherwise, take take cost and recursive solve for increase increment each of them. Otherwise, skip, then 0, and then just move the factory pointer. Return minimum of take, comma, not take. Solve of this. And I was getting MLE with the cache thing for 1e6 or something like that. Uh, I had to use f dot cache underscore clear. This thing will not give MLE type shit. And manual DP is also there. There's 2D DP I have defined. If DP of ij is not zero, not equal to minus one, return DP of ij. DP of ij is minimum of take, return DP of ij, return fu.